Alright, so we're going to start the Sql Injection module, and Conrad's going to take care of that one for us today.
Good morning, everyone.
Good morning.
I'm not doing this because by any means I know more about these things than Jeremy does. I want to make that clear up there. The reason I'm handling this particular module is to give Jeremy a break.
So thank you very much.
So that he doesn't, have to pull a Fidel Castro and stand up here and lecture for 6 hours straight. If you have not, if you're wanting to follow along here and you have not already gone ahead and registered for login on the Utiliday here, where we've got the login. Go ahead and register so that you have an account so that you can follow along with this application. As Jeremy covered in the first hour here, Sql Injection is going to be the ability to insert SQL commands for our purposes through the website interface, not through some direct connection to the database backend, but still be able to get the database manager on the back end to execute those commands. As he mentioned before, this is a case where a vulnerability is caused by the system mistaking data, actually mistaking executable commands for data. So it brings it in as data, and then it just executes it. Now, today we're going to talk a little bit about your basic SQL injection, your garden variety SQL injection, but we're going to focus more on a trickier type of SQL injection called blind SQL injection. And in order to demonstrate this, we're also going to use a wonderful little open source tool called Sql Map. Now, for those of you who are running a distribution of Backtrack, or Kali, or the Samurai, the SQL Map is already built into that. If you're on Windows, watch the guy next to you or just pay attention to what we have going on up here. Finally, I do want to reiterate that what we're going to be doing here is illegal. Do not try this on your bank's online banking site unless you really know what you're doing. It is a felony in the state of Kentucky to do this activity, even if you're just playing around without the full consent of the person who runs the website. Don't blame me. Okay. All right. To start out, we're going to come over here, and I've got a logon ID set up, so I'm going to go ahead. I'm going to be logged in to Utiliday, and when you are logged in, you'll see it up here at the top. Your ID and your signature will show that you're logged in. And then we're going to go to our OWASP top 10, SQL injection, extract data, user info. If you're following along, everybody see that? Just kind of like straight across on the screen. And that will take us to the user info screen. User lookup. Enter username and password to view account details. So at this point, go ahead, enter your username and your password, and click on View Account Details. Now I've got this blown up to make it a little bit easier to show on the screen. But what you should get in as a result is the information associated with your particular record. Now, this page, as Jeremy mentioned, is indeed susceptible to SQL injection. So we're going to just do the garden variety SQL injection, and this is going to be done by the use of a suffix, just like the one Jeremy showed a little bit earlier. And a lot of times this particular suffix you can just try first of all, without even having to look and burp and try and decipher the code and stuff like this. Yeah, the page is not very well written. This one will work 90% of the time. And it's the same thing we saw earlier. You're going to go ahead and put your name in. It needs to be a known good name. With these SQL injections, it's important to start out with a known good input. So we're just going to use, for our canary, this known good input. Follow it with a tick mark, a space, or 1 equals 1. I like to put in a semicolon because I'm old school. A space, 2 dashes, and a space. So, what this suffix is going to do, as Jeremy showed earlier, is we expect that what's going on here behind the scenes is that there is a comparison going on where it's checking to see if what you have entered, it's checking a column name in the SQL database is equal to Conrad, and it puts the Conrad inside the quote. So what we're going to do is we're going to terminate the quote, as Jeremy saw. We're going to change that, basically it's an if statement, to be always true by putting in the or 1 equals 1, so that that if statement will evaluate to true for every line, every record in the database. And then the semicolon space dash dash space then just says, okay, ignore any other stuff that happens to be in that SQL statement. So what we're shooting for here is to come up with an SQL statement that evaluates to if true. And if we do that, hit the enter button, well, it turns out we got lucky. Sure enough, that one works. That suffix caused the SQL statement, forced it to evaluate to if true, and you should be seeing every record in the database. Was anybody able to follow along this far?
If you need any like text support or whatever, let me know. I'm wandering around.
Okay, that's the basic SQL injection. That's, again, usually done by putting SQL commands where data are supposed to be. For our next follow along here, we're going to move on to a different type of SQL injection. And I'm going to toggle the security on this. I'm going to hit that toggle security link, cause the security level to go to 1. That's simply technical reasons for the purposes of this demo we're going to show you here. It just works better for the purposes of this demo. And I'm going to make sure my browser is pointed to the proxy. If you've been following along so far, your browser's probably already pointed to the 8080 browser. And I'm going to go ahead and submit that again, our known good request. And when I come back to my burp, just as we did before, we're going to see that we have our request that went to the web server. So, what we're going to do from this point on is we're going to use the Sql Map tool, and we're going to use it to automatically do a lot of the thinking and mechanics that Jeremy was going on in the first hour. It certainly is important to understand what Jeremy covered in the first hour, but you know, if you happen to forget, there are these wonderful tools like Sql Map out there. I call them just basically point and hack tools that you can use to do a lot of the work for you. Got the dirty little secret of PenTesting. Now to do that, we have to start out again with, what I'm about to show here, the blind Boolean SQL injection. We have to start out with a known good request. So I'm going to copy this request save it. And make sure I get everything in the right place. You can tell I was practicing this last night, so I've already got one out there. I'm going to replace that one. So this is our request, what it sent to Matilde, and this was not the one with the special SQL injection. This was just the plain vanilla, put your name and password in, your ID comes back. Find my cursor. Actually, at that point, we no longer really need, and we don't even really need the browser anymore, because our next tool, Sql Map, is going to play the part of you sitting here and typing all this stuff at the browser. Now, if you're running Kali, you will find Sql Map right here as one of the top 10 security tools. If you are running Backtrack, you'll find it also under the Backtrack menu, exploitation tools, database exploitation, SQL, and then one of the options out there ought to be Sql Map. Now the first thing I'm going to do is find my cursor. There we are. I do that all the time, thank you. Is be sure I've got it cleaned up. That's not showing up. My colors aren't showing up real well on this. Might have to darken this out here briefly. It works real well. I'm sorry about that, but it works real well when you have it on the screen in front of you. It's not working too terribly handy on this setup here. So I'm just going to do a SQL Map purge output. Depending on which distribution you're using, you may need to use the Linux /SQLmap.py. This one's just set up with a, Jason, what is it called again? Symlink, thank you. This one's set up with a Symlink, so I don't have to do that. But if you don't have that set up, you've got to do the /SQLmap.py thing. Okay. So the next thing I'm going to do is I'm going to invoke SQL Map -r, give it the name of the request, or the location of the request rather, and that is going to be where we stored our request file. And I'm going to let it just go ahead and run. And what it's going to do here is it's going to start out, it's going to pick up the first parameter that it finds in that request. In this case, it was page. And it's going to start going through and testing various types of injections to see if it can determine what database it's up against. and it'll try MySQL, try Postgres, and let me see if I can quickly, because this isn't going to go very far. We can't get this a little bit easier to read. Let's try. Okay. I don't know if that's just going to take effect from here on or what. And what it's doing, for those of you who can't see this, is it's gone through and it's trying to run certain commands to determine if it's MySQL. And it tries to look to see if it's Postgres, and it tries to see if it's Microsoft SQL server. Now, I interrupted it at that point. In real life, of course, you let it go on unless you knew what the backend database was already. So I'm going to tell it to skip on to the next parameter. Still didn't take care of our colors. Well, the next parameter came across was username. And it did some checking, and it says that username might indeed be SQL injectable here. And it did some testing that said the backend database might be MySQL. Do we want to skip the test payloads for the other type of databases? Well, in this particular case, we know that the backend database is MySQL. So we're going to go ahead, we're going to skip the other ones, and we're not going to do all those tests. And we'll let it run through here. And what it's doing is it's trying a series of different canaries, injections, prefixes, and suffixes that are pre-programmed into MySQL. And it's finding out that username is Boolean-based blind injectable. It's also got this error-based where clause injectable. It's a time-based blind injectable. As you would expect, there's just all sorts of different ways that this particular page can be manipulated through SQL injection. Do we want to keep testing the others? No, not in this particular case. We've got what we need to know. It'll tell us all these different things here. So what I'm going to do at this point is I'm just going to kick off the request again. I'm going to specify technique, capital B. This says use the blind Boolean. And I'll explain that here in a minute, exactly what's going on with blind Boolean. I'm going to tell it that the parameter name that we want to take advantage of is username. And then tell, if it can, return what the current user that it's using to actually get to the database backend with. It's going to go off there. You can see it was able to determine the operating system, the web server, and the database backend versions. That tells you a lot right there, what you're working with. And remember, this is just strictly sending requests just as if they're coming from a browser. These requests are going to the web server, not to the database server. Now in this particular case, this type of SQL injection is different from what we did earlier, where we put that suffix on there. You know, we just had it display all the values right there on the screen. What's going on here is that we've told it to give us, to get some information out of here as best it can, but this is not information that is being displayed. This is not coming back in the response from the web server itself. So in terms of what Jeremy was doing earlier, we wouldn't be looking for the canary that we sent out. This is not something where we're checking for, you know, fiddling around with some values and looking for them to come back. We are looking for a way in which the page response comes back that's different if we send in what we know is true, that is something that is congruent with the base request that we originally set up and captured, and then something that comes back when the value that we're sending, the payload that we're injecting in there evaluates to false. And the way it does this is, if you look here, you can see what it's done is it's taken, oh, slow down there. What it's done is it's taken again, this if statement I was talking about on the back end, the username Conrad, and it's added these and clauses on there. And in this particular case, it's set in true values. And it looks to see if, as long as it adds a true truth value onto the end of the base request and it comes back the same, and then it'll change this to 7322 equals 7323, for example, which it knows is false. And if that comes back different, okay, it's got this Boolean value, this Boolean switch that it can use to determine whether or not, or how the SQL command is being interpreted on the back end. All right, well, what good is that going to do, you ask? All right, so for example, you know, it could be returning an error message, or it could be returning just a blank page. Well, what good is that going to do? You know, the other one, where it actually gave us this nice long list of everything that was in the database, that's useful. Well, you don't always have that particular flaw where it's going to come back and dump everything onto the screen. Sometimes the databases actually work this way. And what it has done is it's gone out there and it has built a Boolean expression here using the MySQL function current user equals, or you know, equals a certain ASCII character, and then one by one it has managed to pull each one of these characters out to determine what the current user for that database is. For example, it'll go up here and it will insert, you know, username equals Conrad, and the first character of the current user is A. Well, that's going to come back true or false. If it comes back true, well, then it knows, okay, the first character is A, and it goes on to the second character. If not, it reissues that same command. It says username equals Conrad, and the first character of the current user is B. And it looks to see what kind of true and false comes back there. Now, this is very time consuming. This is not something you could go back to the Mutilide page, and you could sit there and you could type that in yourself. A, B, C, D, and then just look and see whether or not, you know, you got an error message or a blank, you know, coming back, and then write that down on a piece of paper as you came across. Fortunately, you can download Sql Map for free, and it'll do it for you a lot faster. The other way that sometimes works, in addition to simply looking at the content of the page that comes back, whether it's true or false, sometimes the way the programmer has written it, false commands or false requests will take a different amount of time to come back than ones that are true. This can happen if For example, the indices are set up funny on the database, whereas if you're looking up something that's in there, boom, it comes back really fast, and you're looking for something that's not there, it takes a long time for the system to figure that out. Now that can, it's kind of a stochastic process. It's going to depend on network, delays and things of that nature. But sometimes you can extract useful information the same Boolean way by watching which requests take longer to come back than others. In this particular case, though, we're just using, a message on the screen or the lack of a message. Okay, now just to show, more as a parlor trick than anything else, what else we can do with good old Sql Map is now that we have the user, we can specify as a parameter to Sql Map a capital U, and we'll give it that username. Now this is the username that the web server is using to authenticate itself to the SQL server. This is not something that is supposed to be exposed, or, well, as we talked about, isn't exposed in the actual web code itself. We had to figure it out by inference. And we'll tell it, give us passwords. And it's going to do the same sort of thing. There's a function call in MySQL, or a series of them, to go out there and get these passwords. Now, this, of course, is only going to work if the logon ID that we've specified, has the authority to bring this stuff back. If it's not an admin user, this isn't going to work. But again, which I plan for these colors, it's going through here. You can watch the cursor; it'll hop over every once in a while. It's going through. It doesn't actually check every character in sequence. It'll check its ASCII value to see if it's greater than 32, 64, and then kind of do a binary search sort of thing there. But every time you see that cursor hop over another character, that means it managed to pick up another character. Right now it's pulling out the password hashes for that ID that we created. Okay, now do people understand this concept of blind SQL injection and why it is more insidious than the SQL injections where you just show the stuff up on the screen? Yes, sir.
What's a good countermeasure? How do you programmatically prevent that?
Mitigations. Well, first of all, mitigations against any type of SQL injection tend to fall into the same category, and that is where you need to ensure that any data values that come in are treated strictly as data values and do not ever get turned into anything that could be considered executable code. The classic fault in this particular case with SQL injection is where people bring in user-entered input and they just drop it right into the middle of a dynamically concatenated SQL statement. Yeah. You want to be sure and encode, parameterize, the words vary depending on what development environment you're in, these user inputs, because user input is never to be trusted. Another technique that is handy is that you want to be sure that the user ID that is being used by your application does not have privileges beyond the absolute minimum it requires. For example, in this particular case, there's probably no good reason why the SQL ID, or the ID that the web server is using to authenticate itself to the SQL database, has the authority to pull out password hashes. Okay, that's probably a problem right there. Another common technique is also to put your SQL statements inside of stored procedures into your SQL database. It's got some structural, abstract ways of helping in that it helps you think in a way that, okay, this needs to be separated from the, the executable code within your application. In and of itself, it doesn't prevent SQL injection, because you can take a lousy, SQL statement and put it in a stored procedure, a vulnerable one, and it's still going to be vulnerable. But it certainly helps. Also, in most shops of any size, the people who are responsible for implementing new and changes to the stored procedures tend to be in a different group from the people who are responsible for implementing changes to the web application. So you get some extra separation of duties and possibly review of changes in case there's somebody on the inside trying to pull something funny. In addition, cross-site scripting, many of your Flash and Adobe attacks also fall into the same category of things that the developer, expected to be data, actually come in and are interpreted as executable code. This is just a very large family of vulnerabilities. Recently, Bit9 hacked earlier this year was an SQL injection. The big Sony hack. That was a SQL injection, and one of my favorites, the lovely Liza Moon attack of 2 or 3 years ago. Again, originally kicked off by SQL injection. So, why we still have this in our applications in this day and age baffles me, quite frankly. I mean, it's been on the OWASP top 10 for years now. It shows up even in newer applications that get deployed. And why this is so, I don't have an answer for that one. I mean, it's well known. There are well-known ways to prevent it, so I don't know why it keeps showing up. All right, well, it finally did go through and, using that blind Boolean technique, pull out the entire hash. And so now SQL Map, being the friendly, helpful point and hack tool that it is, wants to know, do you want to perform a dictionary-based lookup on that hash? And sure, why not? And it'll go through it's going through its default dictionary right now. You can specify, custom dictionary if you want to, get one of those off the bulletin boards that people post up there. Oh. Here, text password that matches that hash, TOOR. So, what have you got now? Without actually having a fault in the web application that would display any of this information on the screen, you have been able to get the admin logon ID to the SQL database and the password for that logon ID. SQL Map also has some other things that'll get you the the name of the instance and the table names and the columns and dump data. And at this point, the database is your oyster. I've got a couple other things here I guess I should have mentioned on mitigation attempts. One of the most obvious ones would be don't use SQL. Okay. SQL injection attacks aren't going to work too well if you've just got some text-based file thing that you're reading out of, and a lot of people just wouldn't think of that. So, whitelisting any data parameters that you have coming in. Of course, that's always a really good idea. And as we saw earlier, avoid displaying any error messages on the screen, as we saw until the day before. Now I want to show if I've got a few more minutes here, show adapted from a real life example here, where I looked at a application and up again. Yeah, this was based on a real-life application where I came in, and it took me more than an afternoon to actually do all of this I'm about to show you, so I didn't really think through all of this quite this quickly. But this was kind of an example of what we had with a, come here. There we go. Ding. Case where blind SQL injection came in very handy. This is a SQLOL that I've cut down for the purposes of this demo. And what happened was that when we put certain things in there, in the input, you would get either a got results. If you put Ed in there, and if you put in Pauline, then you wouldn't get anything. So a real Boolean kind of setup. It's not like it displayed any other information that it got out of the database about those people. It was simply doing some checking in the background to see whether or not they happened to fall into this particular table. Now the thing that saved me on this was that the error messages were turned on and returned to the user. Otherwise, I would have had to spend a lot of time just trying to guess my way through this sort of thing. But, when the programmer's nice enough to return you some error information, then, that can really speed some stuff up. So I just want to be sure we get the latest one here. So we're going to do the Ed. Again, you need to have a known good request to start off with when you're doing blind SQL injection. Come back over here, burp. Pick this one up. Make sure this is the Ed. Saved from earlier. Yeah, there it is with the Ed up there. Now, the trick with Ed, still going to have that problem with the colors, I'm afraid, on the Sql Map business, which I apologize for. I didn't have a quick response to that one. So, bear with me, I'm having to change my demo on the fly here. Always a dangerous thing to have to do. What we're going to do is we'll try the same old tick, semicolon, space, dash, dash, space. This is something you're not going to be able to follow along with. This is not in your books. Just watch the screen. And I do submit. Turn off the proxy. And as I said, they were nice enough to give me these error messages here. And I looked at this for a while and saw that this was, it looks like, since I'm going to be inserting in there with Ed, looks like Ed may actually be showing up more than one place in this particular complicated SQL syntax. But I'm counting, and it looks like I don't have enough closing parentheses to get that comment thing to work. So we come back up here, and I'm going to try that. Make sure I get it in the right place. Nope. So once I had that taken care of, well, now I knew that the error message was, I'd gotten rid of the error message, and now I was going to be able to go back and do my Boolean. So this was going to be my suffix, as Jeremy was talking about earlier. And there is a place in Sql Map where you can specify a suffix value to use after each payload that it's going to be submitting. So I was able to stick that in there. And to make a long story short, I found that due to the complexity of the system, there were also some stuff that was getting caught before, where it was submitting these payloads and before the add. So I had to, similarly to what Jeremy did earlier, calculate what was going to need to be put in as a prefix. And Sql Map has a nice facility where you can just drop that in. Finally, what the programmer had done was they had broken up the SQL statement on multiple lines in the program. And this dash dash comment only comments out to the end of that particular line. So what was happening, this was an Microsoft SQL Server backend, is that, okay, it commented out to the end of the line, but then, it saw this second half of an SQL statement was still there, and that kept throwing an error. Well, again, fortunately, I was able to, just like Jeremy was able to do with the span tag, I started a new SQL statement as part of my suffix, new select, blah, 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 so that it would fit in there. And it took me a couple of times to figure out how many parentheses I was going to need. That was a guessing game. I started out with 1, 2, 3, 4, because the error message did not give me the entire SQL statement. So sometimes, even when you're using one of these tools like Sql Map, you're still going to have to do some manual guessing around until you can get that SQL statement to pass the syntax test. But once it did the same blind SQL stuff. All I was doing was looking for the difference between results found and blank, as we saw here, and that's all I needed to go in. I was able to get the current user ID, the names of the tables, the databases that were in that particular instance, columns in the databases, and dump the values out of there. Even though this page was never designed to return any data to the user, it was strictly intended just to return whether or not they were in the database. By using this blind injection, I was actually able to pull that data out of there. Yes, sir?
So, is the parentheses like a null in this case, or the parentheses?
Yes.
Is that null character, or?
No. What happened with the parentheses is that was simply necessary to make sure that the SQL statement became valid. Because without the parentheses.
So would you just keep putting like right parentheses, or did you have to put both parentheses?
It took some guessing. Yeah. like I say, yeah, I just went over this in like 5 minutes. It took me all afternoon, you know, to solve this in real life. But you just kind of like looked at this, and I saw that, okay, it looks like that OR is trying to, okay, that's, yeah, that's okay, so I put that in there. But I also wasn't sure if Ed, as it turned out in this particular case, Ed was showing up more than one place in the SQL command that was being done. So he actually showed up someplace else, and that's where I had to adjust the prefix to be able to handle that. Having the error message come back saved me a lot of time. If I'd had to just kind of like, you know, just blindly, yes, well, maybe I need to write parentheses there, maybe something else, then what I would have had to do is go through and probably actually write some scripts to do all that guessing for me. And Sql Map also has a facility where you can break it out and call your own manipulating scripts to do that sort of stuff if you've got the time. Now, generally, if you're being, you know, you're doing this as your job or something, you're probably not going to have time to do that sort of thing. On the other hand, you know, if you're a real live hacker, and whether you get it in 3 days or 3 months, you know, doesn't really make any difference, then, you know, these guys can have a lot of time on their hands and can break into this using these tools like Sql Map. Okay, so the point of today, learn a little about Sql injection, how we use the concepts that Jeremy covered in the first hour about context, prefix, and suffix, and also talk about particularly blind SQL injection, where you don't actually have to have an application that exposes the information back to the client to pull that stuff out of the database. Any other questions? All right, well, thank you very much.